Let's now look at example 19. Volunteers for a disaster relief effort were classified according to both specialty, which is construction, education, and medicine, and language ability. S being speaks a single language fluently, and T speaks two or more languages fluently. The results are shown in the following two-way classification table. So now let's answer some questions based on that table. And our questions are, the first row of numbers means that 12 volunteers whose specialties is construction speak a single language fluently, and one volunteer whose specialty is construction speaks at least two languages fluently. Similarly, for the other two rows, a volunteer is selected at random, meaning that each one has an equal chance of being chosen. We want to find the probability that his specialty is medicine and he speaks two or more languages. We want to find the probability that either his specialty is medicine or he speaks two or more languages. And we want to find the probability that his specialty is something other than medicine. Okay, so I have copied this and our questions onto another page so that we can work them. And here we are. And you may have noticed that I've made the chart a little bigger because we're going to want to add some things. I'm going to add every row. So this will be 13, this will be 7, and this will be 8. And I'm going to add every column. So let's see, this will be 16, 22, and this one will be 6. And I'm going to go ahead and add this 22 and 6 to get 28. And if I've added everything correctly, this should also add to 28, which it does. Okay, now we'll see in a moment where we're going to use these numbers. But let's go ahead to number 1. So this volunteer is chosen at random, and we want to find the probability that his specialty is medicine and he speaks two or more languages. So he is both a person with M and a person with T, two or more languages, together at one time. So medicine and T come together in this single box right here. They overlap with these two people. So there are two people who both have a specialty of medicine and speak two or more languages out of the 28 that we have total. Or, of course, we could reduce this to 1 out of 14. Now, let's look at 2. Now we're looking at choosing someone who either has a specialty in medicine or speaks two or more languages. Well, everybody in this row has a specialty in medicine, and everybody in this column speaks two or more languages. So we want to get the total of all of them. Now, everybody in the row here would be 8. So that's, I'm just going to do this, 8 plus, and then if I add the additional people in the column that have T, that have two or more languages. Now, we have to be careful. We've already used this 2 because that was part of this 8. So we really just need this 1 and the 3 that's left, so that's 4 more. So, and I'll just go backwards. That's 12 total, the 8 plus the 4, 12 total out of 28. And we can reduce that. Let's see, 4 goes into the top 3 times and into the bottom 7 times. And then, part 3, his specialty is something other than medicine. If we look at this, anyone who's not in the row of M has a specialty other than medicine. So really, these two rows of C and E, which will be these 13 and these 7, 20 people who do not have a specialty of medicine out of 28. And again, let's reduce it. 4 goes into the top 5 times and into the bottom 7 times. And there we have it.